What we are trying to achieve in this project, the Firewall project, is hand in hand with a variety of stakeholders, electric utilities, firefighters, emergency responders, and community organizations. We are trying to develop a risk-informed decision-making platform that integrates three major advancements: tools and algorithms on the analysis of formation, prediction, and behavior of fires on Alaskan lands, tools and algorithms for assessing the vulnerability of the electric power networks in Alaska in response to wildfires, and community health and social vulnerability metrics.
This set of resources of decision support could be viewed as an integrated risk-sharing platform in which different types of information will be shared across stakeholders. There will be the natural environment, basically related to the risk, to the short-term risk of wildfires in the landscape, in the Alaska landscape. The built environment, which is Alaska's preparedness and response to wildfires before, during, and after. And finally, the social environment, basically the social and health vulnerability of the indigenous communities to wildfires in Alaska. Another objective will be to make these models possibly general enough so that they can be used to wildfires in different parts of the world, as well as for other types of natural disaster. Wildfire is a very important issue in Alaska, and its importance is growing. The frequency and intensity of wildfires keep increasing. There have been 2 times more areas affected by wildfires in Alaska over the last decade than over the previous decade. And some reports suggest that the area that will be burned by wildfires will double by 2050 and triple by the start of the 22nd century. So it's very important issues.
The electricity grid in Alaska is unique. It's isolated from the rest of the power grid in the US. And within that isolation, there are around 200 smaller microgrids, again, in isolation with each other. So if there is a problem happening to electric power systems in Alaska in one of these rural communities, it may take hours and days for the electricity to restore. Different from other parts of the US where you can reroute or redirect electricity from your neighbors. This is a challenge specifically to health vulnerable communities. There are hundreds of people in need of electricity for health and well-being. There are a number of people that are using electricity-dependent medical devices for health and well-being. And that wildfires and the resulting electricity outage has been found to be a challenge. Wildfires, the way how they get triggered and behave on the landscape, the way how they interact with the critical infrastructure, like power systems, like communication networks, water systems, and the way how they impact communities and citizens is in itself a multidimensional problem. We cannot think and act holistically against wildfires for better resilience against wildfires if we do not have a knowledge and understanding of how these wildfires are originated and how they behave on the landscape, the dynamics of their interactions with the critical infrastructure, and how they impact the citizens and the communities. And that's the reason why we bring together a number of researchers with seasoned expertise to conjoin resources and to bring knowledge from a variety of domains, hopefully with the hope to co-produce knowledge and better solutions for resilience against wildfires.